Did you know that bottles and cars can roll uphill? You're probably thinking, no, of course not. And also, V, that's not possible. You're obviously not very smart if you believe that. Well, if that's what you're thinking, then you'd be right on one account. I am in fact not very smart. But 1 point for me, because you were wrong. In some places on Earth, items actually can seemingly defy the laws of gravity and even go completely against it. Hello to my fellow curious minds. I'm V, and today I will be telling you about the top 5 mysterious places that defy the laws of physics. Let's jump in. Number 5, magnetic hills. There are several roads in this world that seem to defy the laws of gravity. They've been given many names. Gravity hills, magnetic hills, magic hills, you get it, they're special hills. Cars that are put into neutral on these hills will roll uphill like they're being pulled by a magnet. There are dozens of dedicated sites for people to go to and test these hills out for themselves. Every single continent has more than one, so if you feel the urge to fall uphill, go check them out. Maybe before I explain how they work, so that you retain some amazement and mystery in the moment. So how is this possible? Well, like I hinted at earlier, the hill only appears to be uphill. It's not an actual incline. The surrounding land creates an optical illusion, and our feeble human brains are unable to process that fact. So we truly believe that we are going uphill. I mean, that's the basic gist, but I'm assuming, like me, you guys are gonna want a little bit of a more in-depth explanation. Well, too bad, you don't get one. Kidding, you do. Of course you do. And you're definitely not here to listen to me ramble, so I'll get back on track. In 2003, researchers conducted a study into why exactly our brains process these hills as uphill. They looked into how the absence of a horizon can skew perspective on gravity hills. Scientists at universities in Europe figured out that without a true horizon in sight, our brain will try to fill in the blanks and will interpret our environment based on the landmarks around us. Our brain uses the surrounding landmarks like trees and buildings, which are able to trick our eyes. For example, if everything around you is tilted, just slightly, you'd assume that you're on a slant or going uphill. It's kind of like those rooms that make one person seem huge and another seem tiny. It's all based on perspective. Even though there is proven scientific reasoning behind these magical hills, many continue to create theories and stories surrounding what else could possibly be causing the hills to defy the rules of physics. Initially, people were shocked, thinking that someone had stolen their car or bike when they would return to find it gone. Theories about the hills being magnetic and pulling cars with metal under the surface of the roads also gained traction. Of course, some thought that the cars were actually defying gravity due to a glitch in the matrix or from a magical force. But we know a lot more now, and after experiencing the hills, people are usually inclined to believe the scientific reasoning. But still, it would feel insanely cool to travel uphill with negative resistance. So hey, search up the closest gravity hill to you, grab a level, jump in your car, and roll up a hill. Number 4, sailing stones. Can inanimate objects move on their own? It appears they can. Sailing stones are an incredible phenomenon where large rocks and stones are able to travel far distances without anyone moving them. The stones leave behind a trail in the sand, as though someone had dragged them through it, but there's no footprints left behind. They actually do move without any human or animal interaction. Instead, the nature and environment around them moves them. But how? Many thought that a supernatural force was responsible for the movement, like a ghost, or that the rocks themselves were creatures. I guess like the trolls from Frozen, but really slow. The first documented sighting of these rocks was in 1915, when Joseph Crook visited the racetrack playa site. He noticed that the rocks had shifted, seemingly by themselves. Disagreements over the origin of the moving rocks began to spark, leading people to conduct their own studies in different locations where the phenomena occurred. In 1952, a great deal of attention was brought to the rocks when Life magazine wrote a piece on them. People hypothesized that the rocks were being moved by strong gusts of wind when the ground was muddy. In 1955, geologist George Stanley wrote a paper criticizing the theory. Stanley reminded theorists that the rocks were at times heavier than a grown man, so the wind alone would not have been able to push the rocks, and the mud would have just made it more difficult for the rocks to move. Instead, he offered a theory, which is the basis of the theory we use today. Ice sheets around the stones helped to catch the wind, which initiated the movement of the rocks. The stones are classified as a geological phenomenon. Movement of the rocks occurs when thin sheets of ice floating on a short-lasting winter pond break up in the sun's heat. The rocks are released and able to float off the soft bed of sand, which reduces friction. Then, the rocks are pushed around by the wind, even a very soft, almost non-existent wind, because the friction between the rock and the ground is so minimal. The rocks have been recorded moving distances of over 200 meters. They occur in many different places, but Death Valley in California is definitely the location where the most sightings have been. Honestly, I would be pretty terrified if I had to run in with these rocks before I knew the scientific reasoning. I mean, imagine camping and waking up to an army of rocks surrounding you. I'd assume I was about to be the human sacrifice for some sort of desert cult. Number 3, hindered downfall, or upfall? Now, I'm sure you've heard of a waterfall, but have you ever heard of a water climb? You probably haven't, because I just made that word up. And as you can tell, I'm very proficient in wordplay. I'm talking about the opposite of a waterfall, where water goes upwards instead of falling into a body of water below. The phenomena doesn't consistently occur. Like, it's not a continuous stream of water climbing upwards. Sorry, I made it seem like it was. On purpose. Instead, the phenomena has certain seasons and weather conditions that cause it to occur. Strong winds, which occur more often depending on the season, push the water upwards, but only for short periods of time. The wind has to be really strong though, at least 70 kilometers an hour for this phenomena to occur. They've been observed in Australia, India, Japan, the UK, the US, and really anywhere with winds strong enough to create them. The most powerful and popular reverse waterfall exists in Maharashtra, India. It is called the Nanagot Waterfall, and it is considered the best place in the world to catch a reverse waterfall in action. The ideal time to observe it is during monsoon season, April to September, and anyone longing to view the climbing water must be extremely prepared, as it is not an easy task. First, you must go to Mumbai, and then drive 3 hours to the Nanagot Pass. Then you would hike through forested terrain for 4 to 5 hours, but remember, if you're going to see this waterfall during its peak activity, the weather is going to be rough, so you'll need to prepare all of your equipment for the weather conditions. But then, you will be able to witness the phenomena firsthand, and I'm sure the view would make the trek well worth it. Hopefully you don't run into any of the deadly wildlife India has lurking in their forests. I love the outdoors, and I'm convinced that I'm an animal whisperer, so I'd definitely be fine. But if you decided to make the trek, hire a guide. Don't go at it alone. You're not as delusional as I am. Number 2, Giant's Causeway. Ireland is known for the intense beauty that their country holds, and though I haven't been there personally, I know many people who have, and they would wholeheartedly agree with the observation. One of the most drop-dead, startling sights that you can see in Ireland is the massive collection of columns, forged by none other than the wonderful Mother Nature and maybe some angry giants. The Giant's Causeway is an area of over 40,000 interlocking basalt columns. Most of the columns are hexagonal, but the number of sides does differ. The tallest columns are over 35 feet tall. But how did this wonder of the world come to be? Well, let's travel all the way back to the Pliocene epoch. That's 50 to 60 million years ago. Due to intense volcanic activity, highly fluid molten basalt intruded through chalk beds to form a volcanic plateau. When the lava cooled, it contracted, allowing it to form into the columns. The size of each was determined by the speed the lava cooled at. The fragmenting and cracking during the cooling process is what created the columns we now see. The columns also have legends attached to them, which are actually responsible for the name of the site. Some believe that the columns were the remains of a causeway built by giants. Causeways are railroads on elevated pieces of land, usually surrounded by water. The legend tells the story of Finn McCool being challenged to a fight against a Scottish giant named Benandonner. Finn accepted and built the causeway so the two could meet up and fight. In one version of the story, Finn beats Benandonner, but in another, Finn hides when he realizes that Benandonner is much bigger than him. Finn's wife disguises him as a baby, and when Benandonner sees the size of the baby, he figures that the father must be a colossal giant. Then Benandonner flees back to Scotland, destroying the causeway behind him in fear that he may be followed. The giant causeway is located off the north coast of Northern Ireland, and it is free to visit, minus the plane, the hotel, transportation, but the view is still free. In 2019, over 998,000 people visited the columns. They're definitely a strange and popular attraction, and absolutely high on my bucket list. Number 1, Hudson Bay, Canada. Did you ever try to play the game Light as a Feather? You know that slumber party game where you'd all sit in a circle and try to lift a person up with your fingertips while eerily chanting, light as a feather, stiff as a board? I'm sure you know it, and I'm assuming that it never worked out the way you'd hoped. Well, if you want some help, consider heading over to Hudson Bay, Canada, where scientists say the gravitational pull is lower than anywhere else on Earth. Yep, you heard me right. The gravitational pull in Hudson Bay, Canada is the lowest in the world. People actually weigh less there. It was first discovered in the 1960s, when global gravity fields were being charted. Scientists were baffled by this phenomena, and to most, it doesn't seem possible for there to be less gravity anywhere on Earth. Researchers studied for over 40 years in order to understand the phenomenon, and, well, they believe they found an answer. The basic idea is that gravity on the surface of the Earth varies depending on the mass of the Earth in said location. The cause of less mass in Hudson's Bay is explained by 2 theories, the Laurentide ice sheet theory and the mantle theory. The mantle theory is about, well, Earth's mantle. The mantle is a layer of molten rock, magma, between 100 kilometers and 200 kilometers down below the surface of the Earth. The magma causes convection currents, which drag the Earth's continental sheets down, and then, you guessed it, decreases the mass, which decreases the gravity. The second theory assumes that Earth's mass is lighter in Hudson's Bay because of a giant ice sheet, named the Laurentide ice sheet. During the Ice Age, the entire country was covered by an extremely thick glacier, about 3.2 kilometers thick in most places, and over 3.7 kilometers thick in 2 places over Hudson's Bay. It was so heavy that it squeezed down on the rocks and the Earth that were trying their hardest to support it. When the ice began melting, the Earth tried to return to its previous state, but it took a while. If you need a visual example, find some memory foam and a finger. Imagine your finger is the ice and poke the foam. The foam will attempt to spring back into its original form, but it takes a while. And that's what the Earth was and is still trying to do. But it's not as quick as memory foam. The slow regeneration eventually led to a decrease in the mass of rocks in Hudson's Bay. And well, the decrease of mass came with a decrease of gravity. The Earth regains less than half an inch of mass in the affected areas each year, and it's estimated that it has to rebound 650 feet to return to its original condition. So, safe to say the gravity is going to take a little while to get back to normal. You'll have plenty of time to traverse into the dangerous waters, and even though it might be scary, you'll definitely feel a weight being lifted off your shoulders. That brings us to the end of today's video. I hope you enjoyed it, but more importantly, I hope you learned something. Which of these attractions attracts you the most? Let me know in the comments or send me a DM on Instagram. Thanks again for joining me. I'll see you soon, and in the meantime, remember to stay curious.